Solving linear equations. So the key thing to remember when solving linear equations is that in order to keep the equality true, you must always do the same thing to both sides. And in fact, this is true of solving any equation. So always try to think about each step as, what am I doing to both sides of this equation? So basically we might have 4 steps we need to follow. Some you won't need to bother with depending on the form of your equation. So the first step is to deal with fractions. If you have an equation that involves fractions, write every term in the equation with a common denominator and then multiply each term by that denominator. Now there are shortcuts to doing this, but essentially that's what you're doing when you're dealing with fractions in an equation. The second step is to deal with brackets, and you may have created some brackets dealing with the fractions. The third step is to deal with situations where you have more than one instance of the unknown. So you might have 2x on one side of the equation and 5x on the other side of the equation. So collecting like terms. And then step 4 is you should now have a fairly standard form linear equation by this point, and you simply need to solve the equation by performing the same operation to both sides until you've isolated the unknown. So let's work through some examples. So example 1 is a very standard linear equation. 3x minus 5 is equal to 28. So in any equation solving, we're thinking about what's happening to x and undoing those things by performing the operation to both sides. So in this equation we have x, it's been multiplied by 3, and then we've subtracted 5 from it. So the first thing we want to undo is that subtraction of 5. So we can do the opposite of that, or the inverse operation, which is to add 5. So we're going to add 5 to both sides. I'm not going to write plus 5 on each side. I think it clutters things up. Sometimes you end up writing it on one side and not the other and actually making the equation not true. We should by this point be able to add 5 to both sides of this equation without any extra notation. And so now we have x being multiplied by 3, so we wish to divide both sides by 3 to get rid of that from the left-hand side. And so dividing the right-hand side by 3 leaves us with x equals 11. As with any equation, easy to know that you're right. Substitute x equals 11 back into your original equation and check that it's true. Okay, so the second example. Now this is a simple equation with brackets, and there are actually 2 ways we could go about doing this. So we might have a look at 2 separate methods. So generally I would say if your equation involves brackets, the first thing you should do is expand them. This isn't always necessarily true, but sometimes it's useful just to have a routine that you follow every time you're dealing with equations. So 8 minus 4x is equal to 9. So now I just need to solve for x. So if it helps you to rewrite as negative 4x plus 8, some students find it difficult to recognise what that subtraction in the middle is doing. So remembering that you actually have 2 terms in this equation, a positive 8 and a negative 4x, and you can write them in whichever order you prefer. So now for some people it becomes clearer that what I want to do here is subtract 8 from both sides, which leaves me with 1 on the right hand side. And now I wish to divide by negative 4. So x is equal to negative 1/4. So I want to revisit this same equation, this time without expanding out the brackets first. So the other thing that I could do, if I think about this equation and how it's being constructed, I've got x, it's been multiplied by negative 1, I've added 2 to it, and then I've multiplied everything by 4. So the last operation happening on that left-hand side is multiplying by 4. So the first thing I could do here is to divide both sides of the equation by 4, leaving me with 2 minus x equals 9 divided by 4. So you'll see in this particular example, this isn't a great method because we've created fractions for ourselves very early on in the problem. But if we had this same equation with an 8 or a 12 or a 16 on the right hand side, I would definitely divide by 4 first. I probably wouldn't in this case because 9 doesn't divide by 4 nicely. Okay, so again, if it helps you to rewrite this as negative x plus 2, and now you can see that you're going to need to subtract 2 from both sides. So negative x equals 9 on 4 minus 2. So obviously 2 is the same as 8 on 4, and you might be able to do that in your head without writing out that step. So we have negative x equals 1/4, multiplying both sides by negative 1 or dividing both sides by negative 1, x will equal negative 1/4. So in this case, Not expanding out the brackets results in a slightly more complicated method because it creates fractions very early on in the process. As I said before, though, there are many situations where you might not create fractions by not expanding out the brackets, by dividing by that coefficient of the bracket, and in that case that would be probably a preferred method. Okay, let's have a look at example 3. So here's the first time we've come across some fractions. So these are very simple fractions. Now, as I said, there are lots of different ways to think about fractions in equations, and you can, in many cases, do this with less steps than I do. But I really want you to understand that this is what you're doing at each stage of this equation. So what you're essentially doing here is saying, okay, I've got fractions here. I want to write everything with a common denominator. So I recognise that 7 is 7 over 1. So I've got denominators of 2 and 1. So my common denominator is going to be 2. So I want to write everything in my equation with the denominator of 2. And that's pretty easy in this case because the first term already has a denominator of 2. In the second term of the equation, I've multiplied the denominator by 2, so I need to do the same to the numerator. And the right-hand side of the equation already has a denominator of 2. Now that I've got a common denominator, things become really simple. Because if I multiply everything in this equation by 2, so if I'm multiplying both sides of the equation by 2, so I wouldn't write this, but this is what we're doing. So we're multiplying both sides of the equation by 2, which means 2 times x on 2 is just x, 2 times 14 on 2 is just 14, and 2 times 3 on 2 is just 3. So essentially, creating that common denominator then allows you to cancel it out because you're multiplying everything through by the common denominator, and you've now got rid of your fractions. We've got a very simple equation, subtracting 14 from both sides, x is equal to negative 11. Again, easy enough to check. Okay, second example, again we've got fractions here. I'm going to think about my common denominator, so I've got denominators of 5, 10 and 2, so my common denominator is 10. So I want to write each term in the equation with that common denominator. So that first term, I've multiplied the denominator by 2, so I need to do the same to the numerator. In the second term of the left-hand side, we haven't changed the denominator at all, so the numerator remains the same. And on the right-hand side, we've multiplied the denominator by 5, so we do the same to the numerator. Now multiplying everything in this equation by 10, 2 minus 3x is equal to 5. So we can subtract 2 from both sides and divide both sides by negative 3. Example 5. So no fractions here to deal with, no brackets here to deal with, but we do have more than one instance of the unknown. So we've got x's on both sides of this equation. So there are two different ways that I can deal with this. I want to collect the x terms together, and that's my first priority. So I could obviously do that by subtracting 3x from both sides of the equation, which would leave no x's on the left-hand side and 2x on the right-hand side, or I could subtract 5x from both sides of the equation, which would leave no x's on the right-hand side and negative 2x on the left-hand side. I always do the subtraction to keep things positive, so I'm going to subtract 3x from both sides, leaving them on the right-hand side but keeping them positive. So now we'll subtract 5 from both sides and divide both sides by 2. I'm just going to rewrite it around the other way. So x is negative 7 on 2. Example 6, again we've got x in more than one place in this equation, so we want our first priority is, well actually our first priority is those brackets, so we're going to need to expand out the brackets. The next priority will be to collect the x terms together, and then we should be able to solve from there. So expanding out the brackets, 3x plus 3. Now be careful about this second set of brackets. This subtraction in the middle, this is negative 1 times 2x minus 2. So you're going to have negative 2x and then negative 1 times negative 1, so plus 1. This is the place where you're likely to make a mistake in this equation. Okay, be careful about negatives outside of brackets. Alright, so now collect our like terms together on the left hand side. So we've got 3x minus 2x is x. I've got 3 plus 1, which is 4. And subtracting 4 from both sides, so x equals 0. Again, you should be able to check it easily enough. Example 7. So again we have an equation involving fractions, so that's the first thing we want to deal with. So we've got denominators of 2, 5 and 1, So a common denominator of 10 again. So 10 minus something over 10 equals something over 10. So in the first term of the equation on the left-hand side, we've multiplied the denominator by 5, so we'll do the same to the numerator. In the second term of the equation, we've multiplied the denominator by 2, so we'll do the same to the numerator. Now I'm not going to expand it out, and there's a reason for that, because this is really dangerous here, this subtraction. And you're much less likely to miss it or make an error with it if you don't expand out your numerator. I might show you at the end what would happen if you had expanded it out. Okay, so I'm not going to expand it until after I have got rid of my fractions. And I would say that that's a really good piece of advice to follow in any equation. Alright, so on the right hand side we've multiplied the denominator by 10, so same to the numerator. Now multiplying both sides of the equation by 10 eliminates the fractions. Now I have brackets to deal with, so I want to expand those out, and you'll see this is where you're much less likely to make the mistake. Now it's clear that you've got negative 2 times that bracket. So you're going to have 5x minus 2x, negative 2 times negative 4, so plus 8 equals 30. Collecting the x terms, so 5x minus 2x is 3x. Subtracting 8 from both sides, and dividing both sides by 3. So just want to quickly show you back here, if you had expanded this out, the numerator out in that second fraction, so I'm just going to erase it back here and just show you what would have happened. If we had expanded this out, so if I had immediately written, okay, I'm multiplying the numerator by 2, which gives me 2x minus 8, you're much more likely at this next step when you get rid of the fractions to just write negative 2x minus 8. But actually it's not that. This negative applies to this whole fraction. So it's actually that. But that is the most common, the most likely mistake you'll make with problems like this. So it's much easier to avoid that error if you postpone expanding out the numerator. So leave it as 2 times x minus 4. Then when you get rid of your fractions, still don't expand it out. And now it's much harder to miss that negative in front of the bracket. Okay, last example. Again, we've got fractions, 3 fractions, all with different denominators. My common denominator here is going to be 12. So I'm going to rewrite everything over 12. The first fraction I've multiplied the denominator by 6, so I do the same to the numerator. In the second fraction I've multiplied the denominator by 4, so I do the same to the numerator. And in the right hand side I've multiplied the denominator by 3, so I do the same to the numerator. Don't expand, multiply everything by 12 first. And now expand out your brackets. Collect the like terms on each side, so 6x minus 4x is 2x, 6 minus 4 is 2. Now I've got x's on both sides, so I can either subtract 2x from both sides or subtract 3x from both sides. I'm going to subtract 2x to keep things positive. Now subtracting 3 from both sides leaves me with x is equal to negative 1.